Okay, good day everyone. This is going to be the last topic for coding theory, and in this video we discuss the application of error detection and error correction in product tagging. Product tags are used for easy identification of products as well as for tracking and inventory purposes. Each time you buy a product in the grocery or supermarket or department store, you see some barcodes. And underneath the barcodes are some numbers. Now, each time product tags are transmitted, either by typing or scanning, there is a chance that at least one digit will change or at least two digits will be rearranged. So, for example, if this product was scanned using a machine, okay, there is a possibility that the numbers are transmitted incorrectly. Okay, some of the possible errors in the transmission of product tags are the following. You have single digit, a 4 could be read as 9. Transposition, a 4-5 is transmitted as 5-4, and so on and so on. Now, in order to avoid these errors in the transmission of product tags, we make use of what we call the UPC, or the Universal Product Code. So nearly every item we purchase in the grocery or department store has a UPC on it somewhere. And these barcodes are originally created to help grocery stores speed up the checkout process. So this is to speed up the buying of the products and to keep better track of inventory. Now in this video, we will discuss two types of UPC. We have the UPC 12, so it has 12 digits. So later on, we will discuss the significance of these digits, especially the last one. And we have the UPC 13. An example of a product with a UPC code is this one. Okay, I think this is a product with a UPC 13. Now, what's the significance of the digits of this UPC? Okay, so in order to avoid the errors of transmitting product tags, we apply the method called the check digit schemes. This is an example of error correcting codes which are able to identify errors and correct them automatically as they are being scanned. Most check digit scheme append an extra digit, so we add an additional digit at the end, or digits depending on the product. And as an example, we have the UPC 12. So suppose that we have a UPC 12 with digits x1, x2 until x12 from left to right. Now, what are the significance of these digits? The first digit, x1, is for the specific use of the product. For example, 0 for general groceries, 2 for meat, 3 for drugs, 4 for non-food items, and so on and so forth. And this could be outdated, so you don't have to memorize these things. Now, the next five digits, x2 up to x6, identifies the manufacturer of the product. So companies have these five-digit labels, and then the next five digits, x7 until x11, identifies the product. Now, what about the last digit, x12? The last digit, x12, is called a check digit. So the purpose of this x12 is this is the appended digit, and this is to uh, avoid errors in the transmission of product tags. This digit lets the system determine if it scanned the number correctly or not. So given the 11-digit string x1 until x11, the check digit x12 is appended or added such that the whole 12-digit code word satisfies this check digit condition. Okay? For the check digit condition in UPC 12, the numbers in the odd places are multiplied by 3 and the numbers in the even places are just copied. Now the total sum should be divisible by 10. So let's demonstrate this check digit condition in an example. So let's take a look at this product with UPC 12. In this case, you have x1 is 0, x2 is 7, x3 is 7, and so on and so forth. So the check digit is the last one, 7. Now let's verify that these numbers satisfy the check digit condition. So 3 times x1 plus x2 plus 3 times x3 plus 3 plus x4 plus 3 times x5 and so on and so forth. So if you verify the check digit condition, you will get 80, which is divisible by 10. So how does this check digit condition help in transmission of product tags? Notice that if you scan this product and suppose that this number 4 was read as a 9. If this is a 9, notice that the check digit condition will not be satisfied. And therefore, the computer knows that 9 is not the correct digit. And therefore, it will be corrected automatically into 4. Let's try another example for a UPC 12, this time with this product. So you can verify that these numbers satisfy the check digit condition. Now, as an exercise, I want you to verify if this one is a valid UPC 12 using this check digit condition. Please comment below for your answers. So now we have discussed UPC 12. What about UPC 13? For UPC 13, the principle is the same. This is to see if the product tag scan is correct or not. But instead of 12 digits, we are using 13 digits and we are using a different check digit condition. For UPC 13, the numbers in the odd places are copied as is, while the numbers in the even places are multiplied by 3. The resulting total sum must be divisible by 10. So you can verify that this UPC 13 satisfy this check digit condition. Okay, so you will get 110, which is divisible by 10. Okay, last but not the least is a more complicated product tag known as the QR code. So instead of using numbers, we use a picture for our product tags. This was invented in 1994 for the automotive industry in Japan, and it is designed to allow high-speed component scanning. So this is an improvement of the UPC 12 and UPC 13, and it is detected as a two-dimensional digital image by a semiconductor image sensor. So this ends the discussion on coding theory, and if you have questions, comment below and I will attend to them. Thank you.